Good day, everyone. Welcome to our discussion on the seventh chapter of our topic under Accounting Information System, which is the production cycle. We've already learned in our previous lectures that the production cycle is one of the transaction processing cycles that make up the accounting information system. In this particular lecture, we will describe the major business activities and key decisions that must be made in the production cycle, the threats to accomplishing the objectives of the production cycle, and the controls that can mitigate those threats. We will discuss in details the different processes under production cycle. All right. So production cycle, if you'll think of it, the word production, it gives you an impression that this particular cycle would refer to businesses or companies that produce products. Okay, manufacturing concern. These are manufacturing entities. So if we'll say the business is not manufacturing, but it's just selling items or say consumer goods, are they already automatically out of the production cycle? Not necessarily so. Because while they may not produce products, retailers or businesses, merchandising businesses that sell products or businesses may not concern of the production of products from scratch, which is the conversion of raw materials into finished goods. They may still involve with a production cycle with respect to, say, assembly or creating now bundlings of products, because in a sense they are getting products that are already existing and creating a whole new product by bundling these existing products, say for promo, for certain sale. So in a sense, they would still use the production cycle, but not in its purest form, which is producing products out of raw materials, but rather out of their existing inventories, right? Now, the production cycle um, class is defined as a recurring set of business activities and related information processing operations associated with the manufacturer of products. Okay? So, again, this is a set of business activities. It it compasses now all activities that refer to the manufacture of products. In our next slide, if you the slide deck in your right side of the screen, you'll see there the production cycle being linked to other transaction processing systems or subsystems of an accounting information system. Right? You'll see there, class, the revenue cycle, this part here. The revenue cycle provides the production cycle information in the form of customer orders and sales forecast. A customer order, class, could mean that there are specifications or customizations that are required that the production cycle has to follow in order to make good of that particular order of a customer. um, Say this is a custom built product, like say furniture or fixtures that cannot be mass produced, but rather based on certain measurements, customizations, or design that the customer wants, then the information and the revenue cycle to the production cycle will be in the form of a customer order. But what if the company produces mass-produced products? These are products that no longer are subject to customizations or certain wants or designs by a customer. Then the production cycle would need now information from the revenue cycle in the form of a sales forecast. The sales forecast will be based on certain trends, like say last 3 years of sales by the company. The company was able to create now trends and certain forecasts or expectations that this will be the total number of units that can be sold for the year. And therefore, the production cycle based on the sales forecast will ready itself now to produce the number of units in order that they can match or make good of this particular demand. In return, the production cycle information system, the production cycle department, will send now the revenue cycle and information about the finished goods that have been produced and are available for sale. Okay? Based on that particular sales forecast. Now, the information about raw materials, okay, is to be sent to the expenditure cycle information system. Makita nyo, may arrow dyan leading to the expenditure cycle, and that is in the form of purchase requisitions. An example given here, class, would be based on the sales forecast, there will be 1.5 million units of products that are expected to be sold by the company for 2021. Now, based on our production cycle information, the production cycle would need now 2 units of raw materials to produce now 1 unit of finished goods, meaning the ratio is 2 to 1. Therefore, in order to produce now 1.5 million units of finished goods or the product, then the company would have to need now 3 million units of raw materials. Assuming that the production cycle currently holds now 1 million of raw materials on hand, which is excess now from the previous year, then it means the production cycle would need additional 2 million of these raw material units in order that the production cycle may be able to produce 1.5 million based on the sales forecast. So the 2 million raw materials needed as an additional would now be forwarded to the expenditure cycle in a form of purchase requisition. Okay? And that purchase requisition will prompt now the expenditure cycle to order these raw materials from its approved and select suppliers. The expenditure cycle, class, would also provide now other information, including now the other expenditures such as manufacturing, overhead, and the raw materials spent. Forward it to the manufacturing cycle. The production cycle will also determine if the personnel in the plant or the factory would be enough to cover the demand of 1.5 million units to be produced for the year. If the production department found it wanting and it requires now additional hiring of say 50 people to match the increased production cycle will then have to inform the human resources management cycle in order that they can hire additional people for the job. And the cost of this hiring will then be forwarded by the human resources management cycle or the payroll cycle to the production cycle. And the production cycle will then be a repository now of what? Direct materials, direct labor, and overhead that it will forward to the general ledger and reporting system for the computation now of the cost of goods manufactured. Alright? So, in that case, class, you'll see that the production cycle is actually related to all other transaction processing cycles. In fact, they are interrelated because the production cycle would be dependent from these other cycles in the form of the costing information required for the manufacturing of the products. The other transaction processing cycles, on the other hand, class, would need information from the production cycle in order for them to accurately make orders from suppliers, to hire additional people, and to compute the necessary information in the preparation of the financial statements. Right. Now let's proceed to the production cycle data flow diagram. You'll see here, class, that in our data flow diagram, the production cycle is comprised of four basic activities. First will be product design. Second will be planning and scheduling. Third will be production operations. And fourth will be cost accounting. We will discuss in the succeeding slides in details now these four basic activities under the production cycle, right? But before that, let us proceed first in our summary table on the different activities under the production cycle, and that the threats of these in these different activities, threats that could stop the organization or the company from achieving its objectives, and the different controls that could be designed or that could be introduced to mitigate these threats. Okay, so in short, what are the expected threats, or what are the threats to be expected from these four different activities under the production cycle, and what are the different controls that we may introduce in order that we can mitigate these threats, right? So this will cover, class, now slide 6, slide 7, slide 8, and with that, you can just refer later on in these particular slides or in your PDF as we move forward in our discussion in the different activities, the threats, and the controls related to these particular threats. So that could serve as your basis now as we move forward in our lecture. So you can use the PDF that has been posted in our Diagler as a accompaniment for this video lecture as your guide as we move forward with our lecture. Now let's proceed to our first activity. Our first activity is actually product design, right? This is the first activity. It is the first step in the production cycle. The objective of this particular step is to create a product that meets customer requirements in terms of quality, durability, and functionality while simultaneously minimizing production costs. Okay? Now, the criteria for the planning or designing of a product would often conflict with one another, making product design a challenging task. If you notice, class, that there is a correlation between the price of the product and the quality of the materials that make up for these products. Now, the company would decide sometimes what would be the target demographic of the products. Would these products target now um, affluent clients or affluent customers or high income households, or are products to be marketed to the less affluent households or to those who lower income households? So with that particular goal in mind, the company would then have to consider now the costing in producing the product, and costing is a substantial component of product design. And with this costing now, the design would involve now trading off certain, say, quality of the product or durability in order that the product can still be sold for a lower cost, again, without sacrificing the functionality or the utilitarian part of the product, meaning it can still be used, albeit that there is lower quality or lower durability, as long as the target consumers or the target market can afford buying the product. All right? But what if the company is geared towards affluent household? Then therefore the design would not sacrifice quality or durability of the materials used, but rather would focus now on, say, how to minimize cost in terms of, say, the process involved in manufacturing, that is to avoid like certain customized parts or components, using now readily available parts or components in order that the production process will be straightforward. You don't sacrifice the quality of your product, the durability of the product, hence the costing already of the materials is quite high, but you try to save cost on the process involved, which is the manufacturing of these products. So that's quite a lengthy process, product design. And why is it that product design is quite lengthy? Because it should be final the moment that you launch the design, and that particular design will make or break the company. Because it will, the failure of a product design will trickle down to the different processes involved in a production cycle. Right? Now, the product design activity creates now two outputs class. First will be the bill of materials, and second will be the operations list. A bill of materials is a document that specifies the part, number, description, and quantity of each component used in the product. An example of a bill of materials can be seen in the right side of your screen, which shows you the part numbers, the description, and the quantity. Operations list, on the other hand, is a document that specifies the sequence of steps to follow in making a product, which equipment to use, and how long each step should take. Right? Tools available right now, such as product lifecycle management software, the different technology, um, actually help companies improve the efficiency and effectiveness of the product design process. These software consists of three components: the computer aided design, or CAD, which basically it's quite a common term that you may have encountered already. This computer aided design allows companies now to simulate how products will be manufactured, how the product will look like after they're manufactured, as well as product data management software that stores all data associated with the products. The CAD now may also create now a 3D model of the product, thereby eliminating the cost now associated with creating now and destroying certain prototypes. So the 3D model can already save cost with respect to making a lot of prototypes before trying to create the final one. CAD can also be used by design teams um, in order that companies can determine labor, machine, and process requirements to optimally produce items in different facilities across the globe. Okay. Now, what are the threats in product design? Well, poor product design drives up cost in several ways. Using too many unique components when producing similar products increases the cost associated with purchasing and maintaining raw materials inventories. It also results in inefficient production processes because of excessive complexity in changing from the production of one product to another, and poorly designed products are also more likely to incur high warranty and repair costs. To mitigate this threat, accountants should participate in product design activity because 65 to 80% of product costs are determined at this stage of the production process. Okay? Why there is a participation of accountants at this point in time? Because accountants with figures backed with figures that they know, they can analyze how the use of alternative components and changes to the production process can affect the cost. In addition, accountants can use information from revenue cycle about repair and warranty costs associated with existing products to identify the primary causes of product failure and suggest opportunities to redesign products to improve quality. So based on the summary table that we had there, um, the product design, the threat will be a poor product design that may result to um, higher cost. And how to mitigate that one is to ask your accountants or your finance department to participate in the product design in order that there is a financial analyst or an analysis on the cost related to the design. Meaning, at on hand, the designers can already be told by the finance department that the design that you are trying to propose And the process to manufacture these designs is quite costly, and therefore you have to find ways in order to improve or to lower the cost in producing these products or these designs. Also, accountants can analyze the warranty and repair cost in order to focus on the quality of the product and also to prevent now faulty products and address now the issues of prior products released. Right? Now let's proceed to planning and scheduling. This is the second step in the production cycle. The objective is to develop now a production plan that is efficient enough to meet existing orders and anticipated short-term demand while minimizing inventories of both raw materials and finished goods. Okay. So ang goal here, class, ng planning and scheduling is we have to meet the orders. Meaning walang backlogs, walang delays in delivering the finished goods or products to the customers, but at the same time, minimize now the inventory for both raw materials and finished goods because excessive inventory of raw materials and finished goods would entail now additional storage cost for the company kasi nga hindi nabenta. And therefore, the goal here is that by minimum, ito lang yung dapat inventory natin ng raw materials kasi ang ginawa natin or na-produce natin na product or goods for the period already sufficient enough to meet the demand based on the sales forecast. Okay? Now, the two common methods of production planning are the manufacturing resource planning and lean manufacturing. Manufacturing resource planning, or we call it MRP2, is an extension of MRP1. What is MRP1? That is materials requirements planning. MRP2 seeks to balance existing production capacity and raw materials needs to meet the forecasted sales demands. It is often referred to as push manufacturing because goods are produced in the expectation of customer demand, meaning there is already a set customer demand for the year and the company only produces to that particular demand. So there is no expectation of excessive finished goods inventory. Just as an extension of materials resource requirements planning inventory control systems, lean manufacturing, on the other hand, extends the principles of just-in-time inventory systems to the entire production process. So, diba, we have the materials requirements planning, which we call just-in-time. When you extend the just-in-time principle, class, with respect to your acquisition or maintenance of raw materials to your production process, we call that one as lean manufacturing. The goal of lean manufacturing is to minimize now or eliminate inventories of raw materials, work in process, and finished goods. Lean manufacturing is often referred to as what? Full manufacturing. Yung sinabi na rin kanina, manufacturing resource planning or MRP2 is push manufacturing, meaning we only produce the expectation of customer demand. Lean manufacturing is referred to naman as the opposite, which is full manufacturing. Full manufacturing because goods are produced in response to customer demand. Meaning, reactive ang lean manufacturing. Walang expectation. There is no estimate, but rather the manufacturing is triggered or activated by customer demand. Theoretically, lean manufacturing systems produce only in response to customer orders. So, hihintayin mo na yung order before magpa-produce. However, in practice, most lean manufacturing systems develop what we call a short-run production plans. Ano tong short-run production plans na to? These short-run production plans are developed on a monthly basis, which is the practice now of Toyota, so that it can provide a stable schedule to its suppliers. The strategy of producing monthly production plans enables now the suppliers to also plan their own production schedule so that when the manufacturing plant would now have to ask for the delivery, these suppliers can deliver their products to Toyota or to the other manufacturing company or manufacturing clients at the exact time that they are needed. Thus, MRP2 and lean manufacturing systems are planned production in advance. Okay, that's the common denominator. They plan in advance. They only differ, class, in the length of the planning horizon, because MRP2 is developed now, or it develops plans for up to 12 months in advance, whereas lean manufacturing used a shorter planning horizon. If demand for the company's product will be predictable, class, and the product has a long life cycle, then the most justified approach will be MR2. Now, in contrast, lean manufacturing is the proper approach or more appropriate approach if the company's products are characterized by, say, short life cycles and predictable demand, and there are frequent markdowns of excess inventory, right? Now, what are the key documents and forms under planning and scheduling? Well, the first one, class, will be the master production schedule, which specifies now how much each of the product is to be produced during the planning period and when that production should occur. Okay? This particular document, the MPS, class, this will contain information about customer orders, sales forecast, and inventory levels of finished goods in order that we can determine now the production levels. Now, the MPS note, class, is the output that is to be produced during the planning period and also when that production should occur. Although the long-range part of the MPS may be modified in response to, say, changes in market conditions, production plans for many products must be frozen a few weeks in advance in order to provide sufficient time to procure now the necessary raw materials, supplies, and labor resources. Take note that specifically for raw materials, it would require or would entail now lead time before they can be delivered by your supplier, and therefore it has to be made in advance. The complexity now of scheduling increases dramatically as the number of, say, your factories or plants grows. For example, a large manufacturing company must coordinate first the production at many different plants in different countries, and some of these plants produce basic components and the others assemble the final product. The production information system have to be coordinated with each other and have to coordinate these activities in order that the company will minimize the possibility of bottlenecks and the buildup of partially completed inventories. Okay? The MPS, or the Master Production Schedule, class, is used to develop a detailed timetable that specifies daily production and to determine whether raw materials need to be purchased. To do this, it is necessary to explode the bill of materials to determine the immediate raw materials requirements for the production goal, and these requirements are compared with, say, the current inventory levels, and if the additional materials are needed, then that would now trigger the preparation of what form again? I've mentioned this one a while ago, purchase requisitions. These are generated and then they will be sent to the purchasing department to initiate the acquisition process, which, if you could remember, under the expenditure cycle, will result now to the preparation and the creation of purchasing order. Okay. Now, another document class that is an output of planning and scheduling activity will be the production order. The production order is a document authorizing the manufacture of specified quantity of a particular product. It lists now the operations that need to be performed, the quantity to be produced, and the location where the finished product should be delivered. It also collects data about each of those activities. Now, materials requisition, on the other hand, authorizes the removal of the raw materials from the storeroom, say the warehouse, and the delivery of the same to the factory location where they will be used. This document contains the production order number, the date of issue, and based on the bill of materials, the part numbers and quantities of all necessary raw materials. Subsequent transfers of raw materials throughout the factory are documented using we call the move tickets. Okay? These move tickets identify the parts that are being transferred, the location to which they are transferred, and the time of the said transfer. Notice, class, that many of the documents that are used in the production cycle pertains to tracking of movement of usage of raw materials. Therefore, it is expected that there will be use of barcoding and radio frequency identification tags in order to provide opportunities to improve efficiency and accuracy of these materials handling activities by eliminating the need for manual entry of data. Because again, manual entry of data will result now to human error. And human error is very critical, especially in the planning and scheduling process of the production cycle. Okay? Now, the radio frequency identifications I've mentioned, they usually also used to locate specific inventory because the scanning devices are not only limited to reading only those items that are directly in line of sight, but they can also be used in large warehouse and storage facilities where items may get moved around to make room for new shipments. All right? Okay. So what are now the threats to your production cycle? Okay. The the threats now, okay, the primary threat in the planning and scheduling activity is over or under production. If you'll see overproduction, it can result in a supply of goods in excess of short-run demands, thereby creating a potential cash flow problems because your resources are already tied up in inventory, meaning you've already spent your cash for inventory acquisition and they are not being sold, and therefore you will be in a negative cash flow. You will be cash strapped. You will be scrambling for cash. Overproduction also increases the risk of carrying inventory that may be rendered obsolete. Conversely, underproduction can result in lost sales and customer dissatisfaction because of lack of availability of desired items. These threats are especially important for companies that produce new innovative products such as current fashion clothing because the demand for such products is much more volatile than the demand for staples and commodities such as food or supplies. The production planning systems can reduce the risk of over and underproduction by improvement requires accurate and current sales forecast and data about inventory stocks, information that the revenue and expenditure cycles can provide. In addition, to improve the forecast, information about the production performance, particularly concerning class the trends in total time to manufacture each product should be regularly collected. These data sources should be used periodically to review and adjust the MPS. The MPS is the manufacture. What is MPS, by the way? The master production schedule. Right? Now, proper approval and authorization of production orders is another control to prevent over or underproduction of specific items. It means that there is a need of careful review and approval in order to ensure that the correct production orders are released. The risk of unauthorized production orders can be reduced by restricting access to the production scheduling program. Right? Now, so this is the summary now in this right side of your screen. Planning and scheduling, the threat is over and underproduction. And these are the three controls that you may introduce in order to mitigate the threat of over and underproducing based on the sales forecast. Okay. Let's proceed to production operations. Let's third step in the production cycle, which is the actual manufacture of products. The manner in which this activity is accomplished may vary greatly across different companies, since these companies may differ according to the type of product that they are manufacturing and the degree of automation used in the production process. Now, for many big companies using various forms of IT or information technology in the production process, such as robots and computer-controlled machinery, they are called CIM, or Computer Integrated Manufacturing. CIM is a manufacturing approach in which much of the manufacturing process is performed and monitored by computerized equipment, in part through the use of robotics and real-time data collection of manufacturing activities. CIM can significantly affect the production process. For example, class, the 3D printing dramatically reduces the time and cost to make products, kasi the 3D printing now eliminates the lengthy process of producing the prototype. 3D printing also makes it possible to build products that could not be made using traditional manufacturing processes. The ability to attach sensors to every piece of equipment, part of what's sometimes called the industrial Internet of Things, makes it easier to ensure that preventive maintenance is done, thereby avoiding costs and delays due to breakdowns. Now, accountants need not be experts on every facet of the computer integrated manufacturing. But it is important, or it is imperative, that accountants or cost accountants or management accountants, that they must understand how it affects both operations and cost accounting. One operational effect of CIM is a shift from mass production to custom order manufacturing. This capability requires redesign of the inventory management systems and the workflows to facilitate quick changes in the production process. As we will discuss as we move forward in our succeeding topics, you'll um, you'll realize later on that the flexibility in manufacturing operations would have a tremendous or massive effect for the design of cost accounting systems, right? Now let's proceed to the threats of the production process itself. The first one would be theft of inventories and fixed assets. This will be the major concern. Okay. In addition to the loss of assets, theft also results in overstated asset balances, which can lead to erroneous analysis of financial performance and under production. To reduce the risk class of inventory loss, physical access to inventory should be restricted and all internal movements of inventory should be documented. Thus, materials requisition should be used to authorize the release of raw materials to production. Both the inventory control clerk and the production employee who will receive now the raw materials should sign the requisition to acknowledge that then and there the raw materials were released to the production. The request for additional materials in excess of the amount specified in the bill of materials should be documented and authorized by supervisory personnel. Move tickets should be used to document subsequent movement of inventory through various stages of the production process. The return now of any materials not used in the production should also be documented wherever feasible. Yung ating tinatawag na tagging or barcodes should also be used to automate the tracking of inventories. One important control is the proper segregation of duties in order that the inventories are to be safeguarded. Maintaining physical custody of the raw materials and finished goods inventories is the responsibility now of the inventory store department. Department or factory supervisors have primary responsibility for the WIP or work in process inventories. The authorization function, represented by the preparation, say, of the production orders, materials requisitions, and move tickets, is the responsibility of the production planners or increasingly of the production information system. Now, consequently, proper access controls and compatibility tests are important to ensure that only authorized personnel have access to records pertaining to inventories in order that the inventory movement are properly recorded and there is maintenance of accurate perpetual inventory records. Finally, an employee that was not given any custodial responsibility should periodically count inventory on hand, and any discrepancies between the physical count and the one that can be found in your records should be investigated. Similar controls are also needed in order to safeguard fixed assets. First of all, class, fixed assets must be identified and recorded so that managers can be assigned with responsibility and accountability for fixed assets under their control. As with inventory, security measures should be in place to control physical access to fixed assets. And because manufacturing machinery and equipment are often replaced before they are completely worn out, it is important to have a formal approval of the accurate record of their sale or disposal. Okay? There should be a report of all fixed asset transactions that are to be printed periodically and that are sent to the controller. What will be the controller? What will the controller do? The controller would then have to verify that each of the transactions were properly authorized and executed. The cost accounting system would also have to need to maintain accurate records of acquisition cost, any improvements and depreciation in order to properly calculate the gain or loss arising from such transactions. Poor performance is another threat to production operations. In 8.1, if you'll see there in your table, training is one way to mitigate this threat. Indeed, surveys of manufacturing companies report a direct relationship between time spent on training and overall productivity. It is also important to regularly prepare and review reports of performance in order to identify when additional training is needed. Okay. Another threat class, if you'll see there, will be number 9, which is suboptimal investment in fixed assets. Um, this this particular problem can be addressed, okay, um, because another if you remember before when I discussed that overinvesting in fixed assets can create excess cost and underinvestment can impair productivity, and therefore uh, both of these problems can reduce the profitability of the company. So there should be proper authorization of fixed asset transactions. Acquisitions of fixed assets represent a special type of expenditure and follow the same basic processes. There is an order of the fixed asset, then you receive it, and then you pay it. And control procedures of these particular fixed asset acquisition are also needed. Now, the size of most fixed asset transaction necessitates a certain modification of the usual procurement process. Why? Because yun nga, mas mahal than the regular acquisition of inventories. A supervisor or manager who provides details about expected cash flows and other costs and benefits of the proposed expenditure should be the first one to recommend large capital expenditures. And all such recommendations will then have to be reviewed by a senior executive or the executive committee, and the various projects are to be ranked by priority. Smaller capital expenditures can be purchased directly out of the departmental budgets kasi nga smaller amounts. The threshold or the amount level can be set by the management if they want to. All right. And holding managers accountable for their department's return on the fixed asset provides incentive to control such expenditures. Now, another difference class is that orders for machinery and equipment almost always involve a formal request for competitive bidding by potential suppliers. A document which we call in other as RFP or request for proposal specifies now the desired properties of the asset, is sent to each prospective supplier, and the capital investment committee would then review the responses from the select bids. Once the supplier is selected, The acquisition of the asset may be handled through the regular expenditure cycle process, as discussed in our previous episodes or our previous lectures. Another threat class is that both inventories and fixed assets are subject to loss due to fire and other disasters. Thus, physical safeguards such as fire suppressant systems are designed to prevent such disasters. However, because preventive controls are, say, not really 100% effective, organizations also need to purchase adequate insurance to cover such losses and provide for replacement of these assets. Okay? Now, a related concern for this particular loss of inventory or fixed assets would be the disruption of the production activities, which is in number 11 threat. The high-level automation of production cycle activities means that disasters such as power outages not only interrupt the functioning of the information systems, but can interrupt altogether the manufacturing activities. Therefore, it is imperative that there should be backup power sources such as generators and uninterruptible power supply devices that should be acquired to ensure the critical equipment and machinery is not damaged by sudden unexpected loss of power and that important production processes can continue um, on schedule. Okay? Companies also need to investigate the disaster preparedness of key suppliers and identify alternative sources for critical components. This is especially important for companies that practice the lean manufacturing or pool manufacturing principle or approach. They maintain low inventories of raw materials and finished goods, so any disruption to the manufacturing activities or their suppliers can quickly result to lost sales kasi wala kang backup na raw materials or finished goods. Right? Okay, ito pala yung mga different controls. Right. So let's proceed to the fourth process, which is cost accounting. This is the final step in the production cycle. The three principal objectives of the cost accounting system are to provide information for planning, controlling, and evaluating the performance of production operations. It also is designed to provide accurate cost data about products for use in pricing and product mix decisions, and to collect now and process the information used to calculate the inventory and cost of goods sold values that appear in the company's financial statements. To successfully accomplish the first objective, the cost accounting system must be designed to collect real-time data about the performance of your production activities so that management can make timely decisions. Okay? To accomplish naman the second objective class, the cost accounting system must classify cost by various categories and then assign these costs to specific products and organizational units. This requires careful coding of cost data during collection because often the same cost may be allocated in multiple ways for different purposes. For example, factory supervisory cost may be assigned to departments for performance evaluation purposes, not to specific products for pricing and product mix decisions. Okay? Now, let's proceed to the cost accounting process itself. Most companies use either of the two methods or two um uh no methods of assigning now um production cost or process costing. One is job order costing, which assigns cost to specific production batches or jobs and is used when the product or service being sold consists of discretely identifiable items. For example, construction companies use job order costing for each house being built. Similarly, public accounting and law firms use job order costing as well to account for the cost of the individual audits or cases respectively. That's why if you would later work for a firm, since it's job order costing, there is a requirement now for each staff, associates, senior associates, even up to director level to provide timesheets in order that there is proper allocation of cost for each of the particular job. In contrast, process costing assigns cost to each process or work center in the production cycle and then calculates the average cost for all units produced. Okay? process costing is used when similar goods or services are produced in mass quantities and discrete units cannot be readily identified. For example, would be breweries, say yung manufacturer ng beers, they accumulate the cost associated with various processes such as mashing, yung fermentation, filtering, saka bottling in producing a batch of a particular kind of beer and then compute the average total unit cost for that product. Similarly, mutual funds accumulate costs associated, say, with handling now customer deposits and withdrawals, and then compute the per unit cost of these transactions. The choice now of whether to use job order or process costing affects only the method used to assign cost to products, not the methods used to collect the data. Now let's examine now how the data of raw materials used, the labor hours incurred, and the machine operations performed, and the manufacturing overhead are actually collected. Now, um, what are the data to be collected? Obviously, it's raw materials used, okay? Direct labor hours, the machine operations performed, and then the overhead. Now, the raw materials usage data, this is when production is initiated, the issuance of raw materials requisition triggers now the recording of a debit to the work in process for the raw materials sent to production. If additional materials are needed, another debit is to be made to the work in process. Conversely, work in process is credited for any materials not used and returned to inventory. Many raw materials are barcoded so that the usage data can be collected by just simply scanning the products when released from or returned to inventory. Increasingly, manufacturers now are using radio frequency identification or RFID tags to further improve the efficiency of tracking materials usage. Okay? In fact, RFID tags are applied to individual product companies if they desire adopt a specific identification method for tracking inventory. Now, for direct labor cost class, other manufacturers used a paper document called a job time ticket, and that this was in the past. A job time ticket is a document used to collect data about labor activity by recording now the amount of time a worker spent in each specific job task. This document recorded the amount of time a worker spent in each specific job task. Now, when workers enter this data using online terminals at each factory workstation, okay, because that's their instructions. They have to enter this data in their workstation. Now, to further improve the efficiency of this process, okay, companies now consider switching to coded identification cards, which workers would run through a badge reader or a barcode scanner when they start and finish any task. The time savings associated with using barcoding to automate data collection can be significant. For example, Consolidated Diesel Company, which is an American one, found that using barcode scanners to capture data about materials usage and labor operations can save up to 12 seconds per workstation per activity. And when you accumulate this tiny 12-second savings, which may not seem like much, but when you multiply it by hundreds of workstations and multiple activities performed daily by hundreds of employees, that change can result in a permanent 15% increase in productivity. And that 15% increase in productivity is not insignificant. Now let's proceed to machinery and equipment usage. As companies implement now CIM to automate the production process, an ever larger proportion of product costs relate to the machinery and equipment used to make that product. Data about machinery and equipment usage are collected at each step in the production process. Now, for example, when workers record their activities for a particular workstation, the system can also record information identifying the machinery and equipment used and the duration of such use. Until recently, the data collected by wiring the factory so that each piece of equipment was linked to a computer system. This has limited the ability now to quickly and easily redesign the layout of the factory to improve production efficiency. Consequently, many manufacturing companies now are replacing wired connections with wireless technology. By doing so, then, they can now use 3D simulation software to evaluate the effects of modifying the layout of the factory and workflow and to easily and quickly implement beneficial changes. Now, let's proceed to the last one, which is manufacturing overhead costs. The manufacturing costs that are not economically feasible to trace directly to specific jobs or processes are considered manufacturing overhead, meaning hindi directly related to the production of the product or did not take form part of the finished product itself. Examples of these overhead would include the cost of water, power, other utilities, miscellaneous supplies, the rent of the factory or the plant, insurance and property taxes for the factory plant, and the salaries of factory supervisors. Most of these costs are collected by the expenditure cycle information, which would refer now with the exception of the salaries. Kasi pag salaries, this will be under the human resources system or the payroll cycle, which you will have to later on we will discuss in the succeeding video or the succeeding lecture. Now, accountants can play a key role in controlling overhead costs by carefully assessing now how changes in product mix affect total manufacturing overhead. Accountants should go beyond merely the collection of data and they should identify the underlying factors that drive the changes in the total cost. Say, the information that can be used to adjust production plans and factory layout to maximize efficiency and profitability. Kaya, this information is very important and therefore the accountant should beyond, go beyond mere collection. For example, in some companies, they do require the cost accounting system to be redesigned to collect and report costs in a manner consistent with their production planning techniques. For example, pag lean manufacturing ang ginagamit ang approach, it emphasizes working in teams and they seek to maximize the efficiency and synergy of all teams involved in making a particular product. Consequently, the there is a realization that with lean manufacturing, the collection and reporting of labor variances at the individual or team level may create a dysfunctional incentives to maximize now local performance at the expense of a plant-wide or factory-wide performance. Therefore, when there is a realization out of this, a cost accountant would have to redesign the cost accounting system so that the collection and reporting of cost is in a manner that highlights the joint contribution of all teams that make a particular product para maging system-wide or factory-wide ang incentives at the same time and then it will not be like create a certain competition between different teams. Okay? Now, let's proceed to the threats of under the cost accounting. Well, under cost accounting, the threat would be inaccurate cost data, which can diminish now the effectiveness of production scheduling and undermine the management's ability to monitor and control manufacturing operations. For example, ang inaccurate cost data can result in inappropriate decisions, okay, about which products to make and how to set current selling price. Errors in inventory records can lead to either over or underproduction of goods. Okay. Overstated fixed assets increase expenses through extra depreciation and higher property taxes. Understated fixed assets can also cause problems because, for example, inaccurate counts of the number of personal computers can cause a company to unknowingly violate software license requirements. Inaccuracies in financial statements and managerial reports can distort analysis of past performance and the desirability of future investments or changes in operations. The best control procedure to ensure that data entry is accurate is to automate data collection using now the barcode scanners, badge readers, and other devices. When this is not feasible, okay, online terminals should be used for data entry and should employ various data and edit controls. For example, yung check digits and closed loop verification should be used to ensure that information about yung raw materials used, operations performed, and employee number is entered correctly. Validity checks, such as comparing part numbers of raw materials to those listed in the bill of materials file, provide further assurance of accuracy. And finally, to verify the accuracy of database records, periodic physical counts of inventories and fixed assets should be made and compared with recorded quantities. Okay? Accurate cost data are not sufficient. However, in some companies, poorly designed cost accounting systems may result to misallocation of cost to products and can produce now misleading reports about the production cycle activities, both of which can lead now to erroneous decisions and frustrations. Okay? Now, let's proceed to how do we improve control uh, with um, this particular threads. Let's proceed to um, improving controls, mitigating controls, but in an activity-based costing. Kasi we have two types, diba? Activity-based costing um and um and the other one, which is the job order. No, sorry, activity-based costing systems and innovative performance metrics, we call it. So activity-based costing, which is the traditional cost system used to for volume-driven basis, such as direct labor or machine hours, to apply overhead to products. Activity-based costing can refine or is a process that can refine and improve cost allocations under both the job order and process cost systems. It attempts to trace costs to the activities that create them, such as grinding or polishing, and only subsequently allocates those costs to products or departments. An underlying objective of activity-based costing class is to link costs to corporate strategy. And corporate strategy results in decisions about what goods and services to produce. Activities must be performed to produce these goods and services, which in turn incur cost. Thus, corporate strategy determines the cost. Consequently, by measuring the cost of basic activities, such as materials handling or processing purchase orders, activity-based costing provides information to management for evaluating the consequences of strategic decisions. Okay? Now, activity-based costing systems differ from your conventional cost accounting systems in three important ways, right? First, activity-based cost systems attempt to directly trace a larger proportion of overhead costs to products. Advances in information technology make this feasible. Now, um, when implementing activity-based costing systems class, take note, accountants observe production operations and interview factory workers and supervisors to obtain a better understanding of how manufacturing activities affect cost. Now, the second difference or distinction with the activity-based costing use a greater number of cost pools to accumulate indirect costs such as manufacturing overhead, whereas most traditional cost systems lump all overhead costs together. Activity-based costing systems distinguish these three categories of overhead. First will be the batch-related overhead. An example of a batch-related overhead is when setup costs, inspections, and materials handling. Activity-based cost systems accumulate these costs for a batch and then allocate them to the units produced in that particular batch. Thus, products produced in large quantities have lower batch-related overhead costs per unit than products produced in small quantities. The second grouping would be the product-related overhead. These costs are related to the diversity of the company's product lines. Examples of product-related overhead would be research and development, expediting, shipping and receiving, environmental regulations, and purchasing. Now, activity-based cost systems try to link these um, these activity-based cost systems try to link these costs to specific products when possible. For example, if a company produces three product lines, one of which generally generates hazardous waste, an activity-based cost system would charge only that one set of products for all the costs of complying with environmental regulations. Other costs, such as purchasing raw materials, might be allocated across products based on the relative number of purchase orders required to make each product. Now, the third would be a company-wide overhead. This category includes such costs as rent or property taxes. These costs apply to all products. Thus, activity-based cost systems typically allocate them using the departmental or plant rates. Okay? And the third distinction of activity-based costing from traditional costing is that activity-based cost systems attempt to rationalize the allocation of overhead to products by identifying cost drivers. A cost driver is anything that has a cause and effect relationship on cost. An example will be the number of purchase orders processed is one cost driver of the purchasing department cost. That is the total cost of processing purchase orders, and it varies directly with the number of purchase orders that are processed. As in this example, cost drivers in activity-based cost systems are often non-financial in nature. These are often non-financial variables. In contrast, traditional costing systems often use financial variables such as dollar volume of purchases as the basis for allocating manufacturing overhead, right? Now, now, how do we distinguish the two further pa? Now, traditional cost systems tend to apply too much overhead to some products and too little to others because too few cost pools are used. This leads to two types of problems. First, a company may accept sales contracts for some products at prices that are below their true cost of production. And second, companies may overprice other products, thereby inviting new competitors to enter the market. So the tendency with traditional costing systems is that you might cost your product cheaply compared to what it should have been uh, priced, or you have overpriced your product and thereby making you a very expensive option. And consumers might tend to get the cheaper alternatives. Okay. Activity-based costing avoid these problems because overhead is divided into three categories and are applied using the cost drivers that are usually related to production. Therefore, product cost data are more accurate. Okay? Activity-based costing also makes better use of production data to improve product design. For example, the cost associated with processing purchase orders can be used to calculate the purchasing related overhead associated with each component used in a finished product. Engineering can use this information along with data on relative usage of components across products to identify unique components that could be replaced by lower cost, more commonly used parts. Finally, activity-based cost data improve managerial decision making by providing information about the costs associated with specific activities instead of classifying those costs by financial statement category. Notice that in a traditional cost report, it draws attention to the fact that travel and software costs are above the budget, but activity-based cost report may show activities that are running over the budget and which are not. So basically, it's more of like a proper look into the different cost drivers and seeing if you are over the budget or under the budget. Now, what are the quality control measures that are um, can be introduced? Information about quality cost can help companies determine the effects of actions taken to improve yield and identify areas for further improvement. So if you notice, quality control cost can be divided into four areas. We have prevention cost, inspection cost, internal failure cost, and external failure cost. The ultimate objective of quality control is to get it right the first time by manufacturing products that meet the customer specifications. This often requires trade-offs among the four quality cost categories. For example, increasing the prevention cost can lower inspection cost as well as internal and external failure cost. Many companies have found that increased spending to prevent defect reduces total manufacturing cost. In addition, improved quality control can help companies become greener. An example of which will be Subaru, the car manufacturer. The Subaru plant in Indiana in the United States redesigned its manufacturing process, and it led now to the reduction of the amount of electricity required to produce a particular car by 14%, and thereby totally eliminating waste now that are being sent to the landfills. Right? So as a conclusion, class, the production cycle consists of four basic activities, which we have discussed in detail in total. Companies are continually investing in information technology to improve the efficiency of the first three activities. However, for the last activity, which is cost accounting, okay, um, um, wala masyadong investment in the IT because the business will reap the full benefit of the changes to these three activities by the corresponding modifications. This can already be felt in the cost accounting system. In addition, accountants need to modify financial reports and develop new measures that more accurately reflect and measure the manufacturing performance. Right? So again, much of the investment will be on the first three activities, and this will be felt now in the fourth activity, which is the cost accounting. Right? So this will be the end of our lecture introduction cycle, and next video will be our discussion in human resource management and payroll cycle.